Hi everyone, it's Mr. Jones, and I am going to be starting our new Year 9 topic today, Violent Planet. So the things we'll be looking at in Violent Planet is a lot of natural disasters. So we're going to look at earthquakes, we're going to look at volcanoes, and we're going to look at tsunamis. But we need to understand where do they come from. So our first lesson is going to be on plate tectonics. Please take a second to write down the title and then press play when you're ready. Okay, so our objectives today. All of you will know that the outer layer of the Earth is broken up into plates. Most of you will complete a table about continental drift, and some of you will write a detailed paragraph to back up Alfred Wegener's theory of continental drift. So, tectonic plates. That's what we're going to be looking at today. I'd like you to concentrate on the image on your PowerPoint. These are the tectonic plates. This is the crust, the outer layer that we live on in the Earth. What I want you to notice is the outer layer isn't one whole object like a 3D sphere. It's made up of larger and smaller plates. Imagine it like a 3D jigsaw. You've got the larger plates, such as North American, Australian, African plates, as you can see here, and you've got some of the smaller plates, the Philippine plate, the Caribbean plate, the Indian plate. These all make up our crust. Some of the largest plates are the North American and Eurasian, and then even the smallest plates, like the Nazca or the Philippine plate. Everybody plays a part in making up the crust. Okay, that's the area around our world. You can have ocean on top of the crust and you can have continents. What I would like you to do is on the left, could you please put a list of the first section of large continents, large tectonic plates, sorry. And then could you please add a list on the right of the small tectonic plates. You might need these for future references and lessons. So please could you copy those both into your book and press play when you're ready to go. Okay, so the Earth's crust, tectonic plates. I've shown you here 3 plates and how they might be collided together. This is the crust. The plates make up something called the crust. It's about 30 miles thick. This crust can run under continents or mountains, and it can run under the ocean. This is a very basic sketch, but it shows you what I mean by many plates are stuck together and they're under where we live. So it's under the continents and the big mountain ranges and the land, and it's under the ocean. It's the bottom of the ocean, which we rarely discover. So could you please copy this basic sketch into your book? It doesn't need a lot of detail, just as simple as I've done it on the PowerPoint. It shouldn't take you long, so could you please pause the video and replay when you're finished. Okay, welcome back. PANGEA, the supercontinent. Fantastic name for it, a supercontinent. This was about 299 million years ago. As you can see on this image, unlike the one I showed you earlier, all of the continents and the plates are connected. This is why they described it as a supercontinent. This is how the world once looked 299 million years ago. And there was a German scientist who created a theory on why it doesn't look like that anymore. So have a little look at these photos, have a little bit of an investigation, have a look at what countries are where, what plates do you think they're on. For example, you can see Russia and China here, and Europe, so you've got the Eurasian plate. Okay, so you can have a few seconds to have a look at these images, and then press next to, press play again to move on to the next slide. Alfred Wegener. This is the man we're going to be looking at today. He was born in 1880 and he was a German scientist. He was the first person to suggest that the continents were once joined together. So PANGEA was close to his theory, that they slowly moved apart over time. This means the crust they were sitting on was moving too. In 1912, he called his theory continental drift. So you imagine drifting, moving around, the continents moving. However, at the time, many scientists refused to accept his theory, saying his ideas were rubbish and impossible. We're going to look at today, what evidence did Alfred Wegener have? So to look at this, we're going to be discussing what arguments Alfred Wegener made that he was correct. And how we're going to do this is we're going to use this research table here. As you can see, I've got an evidence column. You will need to draw this into your book. 1, 2, 3, 4, 5 squares here, and 5 extra boxes for your explanation. The resources that I've attached will be labelled A, B, C, D, and E. So you can write A, B, C, D, E here. Once you have done that, I'd like you to pause this video and go find the research, the resources that support Wegener's theory. You'll find these below the PowerPoint. What you will do then is write the letter in here, which piece of evidence, and tell me how does it support Alfred Wegener's theory that the continents were once together and that they've moved apart. If you need any help, please talk in your Teams chat, but it's quite self-explanatory, but this needs to be filled in with quite good detail. You need to really tell me why this point supports Alfred Wegener's theory. So you can pause the video and press play when you're ready. Okay, welcome back. You should have a full table now with all 5 pieces of evidence. Now we're going to put it into a writing frame. So we're going to just finish the lesson with a continental drift evidence. Alfred Wegener said that the continents were once joined together in one supercontinent called PANGEA, and that they have drifted over time. I've helped you with the first 2. The first piece of evidence is the shape of the continents. Some of them look like they were once joined together. You can go into more detail here and give Africa and South America as an example. The second piece of evidence is that the same animal fossil has been found on continents that are thousands of miles apart today. This must mean that the continents were once joined, allowing animals to walk across. The third piece of evidence is mountain ranges like the Himalayas. These could have only been made if, and you've done your research there with the resources, and now it's over to you to fill in the third piece of evidence and the fourth piece of evidence and the fifth piece of evidence. Once you've done that, you should have a much better understanding of continental drift, and we should have hit our 3 objectives, and that will prepare you now moving on to the lessons ahead. Thank you very much for listening. You can pause the video. If you have any questions, please ask your teacher in your Teams chat. Thank you very much.